A plumber charges $180 for the first 2 hours of service plus a constant hourly rate for additional hours. If a 6-hour service costs $420, which function f models the total cost f of x for x hours of service, where x is greater than or equal to 2? Okay, let's first highlight all the key information that we have here. So we know a plumber charges $180 for the first 2 hours, and then a constant hourly rate for additional hours. A 6-hour service costs $420, which function represents f of x total cost for x hours of service. Now, x is greater than or equal to 2 makes sense because we're talking about hours on top of the first 2 hours. So let's break this down even more. Suppose we have a plumber, right? We have 1 hour he works, 2nd hour, 3rd, 4th, 5, and then 6. 2 hours, 3 hours, 4, 5, and then the 6th hour. Okay? The first 2 hours he works costs $180. Okay? That's just here. Then this remaining amount for the remaining hours will be something else that needs to add up to a total of $420. Right? This is just breaking down the scenario and understanding the context. We're saying 6 4 hours of work, which is what we demonstrated here, costs $420. So that means that initial $180 for the first 2 hours, plus whatever is missing here, has to add up to $420. We see that that ends up being $240. Okay? So 4 hours of work, right? 3, 4, 5, 6, 6. So total hours, so 4 additional hours cost $240. Okay, that makes sense. Cool. So then how much did he charge per hour? Well, we know how to do this. That's 240 divided by 4, right? So $60 per hour after the first 2. Okay, great. So we understand the context, but now we actually have to include some math into this, right? We need to understand how do we do this and to create a function that illustrates this scenario. Okay, so a 6-hour service costs $420. Let's come up with a let statement. Let R be the rate per hour after, this is the key here, the initial 2 hours. Okay, well, using a function f of x is the total cost. We know that the total cost of 6 hours, and we're plugging in 6 for x because that's the number of hours, will be $420. Okay, what does that look like? 180 of that will be for the first 2 hours. And then as we demonstrated before, the remaining hours to make a total work session of 6 hours is 4 hours times the rate R. Okay, and then, again, look, it's just a basic algebra expression, one-step equation, just solving for R, or two-step. We're going to subtract 180 on both sides. To cancel this out, we get $240 is equal to 4R. Divide both sides by 4. R is equal to 60. Great. Okay, so we get the same answer, right? We understand the context. We can also show that in terms of a mathematical equation. So we say that f of x is equal to 180 plus x hours times the rate. Now see, this would be very close to being true, but it's not. The reason is because this tells us that the total number of hours worked is x. But we're not looking at that. We're looking at additional hours. This amount comes from the first 2 hours. So what we end up having to do is saying, well, it's actually $60 times the number of hours worked minus 2. And we see this because if I said the total number of hours worked is 6, 6 minus 2 is 4. So 4 times 60 plus 180 gives us 420, which is what we wanted, right? Now, we could say the same thing. Well, what if we worked 10 hours, right? What if x equals to 10? then the additional hours on top of the initial 2 is actually just 8. So the equation is 180 plus x minus 2 times 60. We're going to simplify that. 60x minus 120 gives us 60x plus 60. This is the equation to represent this. Okay? Cool. An IT technician charges $250 for the first 2 hours and a flat hourly rate after that. A 4-hour visit costs $370. What function f models the total cost for x hours of work? Again, x is greater than or equal to 2. Very similar to the first example. Take a second to see if you could figure it out on your own. Let's highlight the key information. Charges $250 for the first 2 hours, a flat hourly rate after that. A 4-hour visit costs $370. What function represents this? Okay, let's break it down again. Using our example, we know that a 4-hour service, 1 hour, 2 hours, 3 hours, we're going to add a 4th one, 4 hours, okay? The first 2 hours cost $250 for the IT technician. That's just these 2 first hours. After that, there's some sort of fee, right? Some sort of amount here of dollars. We don't know how much yet. But we know the total cost for this will be $370 for these 4 hours. So we can break this down just like we did before. We're going to say $250 plus some sort of rate, R, multiplied by the amount of additional hours, which is 2, right? We have the 3rd hour and the 4th hour that we're still missing. So 2R is equal to 370. Okay? So we can subtract 250 from both sides to solve for whatever R is. So minus 250 minus 250 cancels out. 2R is equal to 120. Divide both sides by 2. 2's cancel out. R is equal to 60. Okay? So what this says is that, okay, he comes in, he works these first 2 hours, he gets paid $250. Then each hour after that, it's another 60. So plus $60 plus another 60, which gives us a total of 370. Using function notation, we say f at 4 is equal to 250 plus 2R, which is equal to 370. This, again, R, is the rate per hour, per additional hour. Like we did before, we subtract 250 on both sides, divide by 2, R equals 60, right? We get the same exact answer. Thus, f of x is equal to 250 plus 60 times the number of hours worked minus 2, because 2 represents the initial, the 2 hours that cost $250. Okay? Now we simplify this. 250 plus 60x minus 120 equals 130 plus 60x. And this is the equation that represents this. Okay. So a function g of x is equal to 3 minus 0.22 x minus 2 models the price of milk in dollars per gallon x months after July. What does the value 3 represent? So this is actually going backwards from what we were doing before. Now we're given the formula, the equation, and we're trying to find the context, right? Before they were giving us the story, the context, and then telling us find the equation. So now we need to understand, what does this equation actually even mean, right? So we could approach this 2 different ways. We could play around with the original equation. For example, let's expand it to understand what's going on. So 3 minus 0.22x plus 0.44 is equal to 3.44 minus 0.22x. So what we can understand here, take a look. The price of milk in dollars per gallon X months after July. So X represents the number of months. The price of milk is G of X. So if the number of months X is equal to 0, means that it is July, right? 0 months passed. We plug in 0 for X in here. This just becomes 0. And the cost of milk is just 3.44. That's the price in July. Then we say, okay, what if X is equal to 1? What month is it? Well, that's going to be August, because that's 1 month, X months after July. So it's 1 month after July. Okay, in August. So let's plug in 1 into our equation here. And I'm going to show this a little more in depth here, just so we make sure we understand. The price of milk per gallon is equal to 3.44 minus 0.22 times 1, which is just 0.22. So then we subtract, we get 3.22. What does this tell us? This is the price of milk per gallon 1 month after July, which means in August, the price of milk was 3.22. Okay? What if X is equal to 2? What month is it? Well, it's going to be September. Let's see what happens. G of X is equal to 3.44 minus 0.22 times 2. That's 3.44 minus 0.44. That's 3. This tells us that when it's 2 months after July, meaning in September, the price per gallon of milk is $3. And recall that the question asks us, what does the value 3 represent? Well, the price of milk 2 months after July, meaning in August. Another way you could have approached this is by looking at it from the perspective of what we did earlier, right? We're saying that G of X is equal to 3 minus 0.22 X minus 2. If X is the number of months, right? X is the number of months after July, then we could easily see that, okay, well, what happens if I can get rid of all of this? Just stay with 3. Well, I would need to do X is equal to 2 for that. I plug that in, and I end up with 3 minus 0.22, 2 minus 2, which is just 0. 3 minus 0.22 times 0, is just 0, is equal to 3. And what we needed to do was to plug in X is equal to 2 for that. So 3 is the price of milk in September, 2 months after July. Okay? The function p of x is equal to 4.15 minus 0.25 times x minus 1 models the price per gallon of oil x months after January. Okay? What does the constant 4.15 represent? So using the more direct approach, we see p of x is equal to 4.15 minus 0.25 x minus 1. Okay, well, we notice something peculiar here. We say, okay, if we plug in x is equal to 1, we can get rid of all of this. And we see that this will end up on its own. So let's try that. P at 1 is equal to 4.15 minus 0.25, 1 minus 1, is equal to 4.15 minus 0.25 times 0, becomes 0, 4.15. Cool. Well, what does that represent? Well, this is the price of gallon of oil when x is equal to 1, meaning 1 month after January, which basically means in February. Right? So the price in February. Going about it the second approach, like the one we did above before, was kind of just expanding it all. So 4.15 minus 0.25, and then times x. So times x minus 0 plus 0.25, 4.4 minus 0.25x, And then you plug in the scenario, what if x is equal to 1? What if x is equal to 2? And then so on until you get just the answer of 4, and then you see, oh, that's the price in what particular month, okay?